And let's take a look at factoring special products. Now just to review factoring a little bit here. Our first method of factoring was the GCF, and that stood for greatest common factor. Remember, we always try to do that. Our second one was grouping, and that's when you have 4 or more terms. Our third method was the PSD method, and that's when it's of the form x squared plus bx plus c. You have x squared x, no x, and there's no number in front of your x squared. Our fourth method is the key number, and that's when you have it of the form ax squared plus bx plus c. You have x squared x, no x, and you have a number in front of your x squared. Our fifth method is dots, difference two squares, and this is 2 terms with a minus between them. So 2 terms with a minus between them. Our sixth one is the difference of 2 cubes, which is 2 terms with a minus between them. And our seventh one is the sum of 2 cubes. And this is where you have 2 terms with a plus between them. There's actually a 8th one, perfect square trinomial method. But perfect square trinomial method, you can do every one of those problems with the PSD and the key number. So, and you see them so seldom that they're not really worth the effort to learn that method. Let's take a look at our first one here. We've got x squared minus 49. Well, first thing is GCF. We don't have anything in common. Groupings, 4 more terms. Nope. PSD and key number will 3 terms, so that doesn't fit. Dots, difference 2 squares. 2 terms with a minus between them. Well, that fits. What we try to do is we try to write a something squared minus something else squared. And we look at the x squared, we ask ourselves what times itself gives us x squared, and that's x times x. And we look at the 49, we ask ourselves what times itself gives you the 49, and that'd be 7 times 7. So we were able to rewrite this as something squared minus something else squared. This is actually a formula. I'll label this as F for what's in my first set of parentheses, and I'll label this as L for what's in my last set of parentheses. And the formula says you take what's inside your first set of parentheses, you add what's in your last, and you take what's inside your first and you subtract what's in your last. So everywhere I have an F, I'll plug in X, and everywhere I have an L, I'll plug in 7. So this becomes X plus 7 times X minus 7. No, almost nobody ever uses the formula. You just take what's inside your first set of parentheses, you add what's in your last, take what's inside your first, and you subtract what's in your last. Let's look at our next one. Got 9y squared minus 16. Unfortunately, they tell you to factor the difference 2 squares, but let's say they didn't say it. GCF, don't have any. Groupings, 4 more terms. No, that doesn't fit. PSD and key number will 3 terms. That doesn't fit. Dots, 2 terms with a minus between them. Well, that fits. So we're going to try to write it as something squared minus something else squared. Now we start with our first piece here, the 9, and we ask ourselves what times itself gives you the 9, and that'd be 3. Then we go to the y squared. We ask ourselves what times itself gives you the y squared, and that'd be y. We go to the 16, and 4 times 4 gives us 16. So we wrote it as something squared minus something else squared. So we'll take what's inside our first set of parentheses, we add what's in our last, and we take what's inside our first, and we subtract what's in our last. And that'd be your answer. Let's take a look at this one. Got 48 x squared minus 3 y squared. Now if I dive right in with the difference of two squares, it's wrong. Don't write this down if you're writing this down as I'm doing it. If I dive right in with that, I'd say, okay, what times itself gives you 48? Nothing. What times itself gives you the x squared? X. What times itself gives you 3? And you think nothing? So you'd say prime. You can't factor this, which would be incorrect. Because remember, our first method of factoring, if I scroll up there, is always GCF. So you look for what they have in common. Well, these both have a 3 in common, both divisible by 3. So I'll factor 3 out. 48 divided by 3 gives us 16 x squared minus, that 3's gone, so y squared. So we did GCF first. And now we'll try difference two squares. Because what's inside the parentheses, we got two terms of my string it. Now the 3 stays out in front. We'll try to rewrite this as something squared minus something else squared. We look at 16 first. 4 times 4 gives us 16. X times x gives us x squared. And y times y gives us y squared. So we were able to write it in that form. So we take what's inside our first set of parentheses, we add what's in our last, and we take what's inside our first and we subtract what's in our last. And that would be your answer. Again, sometimes if you don't factor out GCF, you can't get the correct answer. So always look for the GCF. Let's look at this one. We got x to the 10th minus y to the 8th. I start going through my methods. GCF, there is none. Groupings, 4 more terms, that doesn't fit. PSD and key number are both 3 terms, that doesn't fit. Dots, difference two squares, 2 terms of my string it. That fits. Let's try it. We ask ourselves what times itself gives us x to the 10th, and that'd be x to the 5th. Now, thinking of it going the other direction, remember if we take a power, an exponent, we raise it to another exponent, we multiply them together. 5 times 2 gives us 10. So going in reverse, a very easy way to do it is just take the exponent here, 10, divide by 2, and that gives you your 5. On this one, what times itself gives you y to the 8th? Well, if I take 8 divided by 2, that gives us 4. So we're going to have y to the 4th. So we wrote it as something squared minus something else squared. So we'll take what's inside our first set of parentheses, we add what's in our last, and take what's inside our first, and we subtract what's in our last. And that would be our answer. Let's take a look at this one. We're still on dots. 32x squared z minus 2y squared z. Well, first thing we do is look for GCF. 32 and 2, they're both divisible by 2, and they both have a z. So I'll factor that out. 32 divided by 2 is 16, x squared, and that z's gone. Minus, that 2's gone, and that z's gone, so we got y squared. Did we just do that one? Yeah, over here. But again, that's my GCF. I would try to rewrite what's inside the parentheses as something squared minus something else squared, and since I already did it over there, I won't go through all the steps again. But this is 4x and this is y. 2z carries down, we can't drop it. Now we take what's inside our first set of parentheses, we add what's in our last, and we take what's inside our first, and we subtract what's in our last. As sad as it is, when I try to make these problems up, I try to be random, but people are not as random as they think. I remember one of the graduate courses I took talked about how to tell if somebody's making up data. There's a method for that. Because you think you're being random when you're making up data. This is for like if you're collecting a survey or something. You don't want your collectors, your survey collectors, just go up and make up data, sit at McDonald's and drink coffee and make up data all day long. So there's a method you can determine to see if they made it up. As weird as that seems. Now this one is a little bit different. It tells us to use the difference two squares. Dots doesn't have to be two terms of minus between them. It can be two anythings with a minus between them. Like on this problem, I can rewrite the 9 as 3 squared minus 2x minus y squared. So as long as you can rewrite it as something squared minus something else squared. Our formula says you take what's inside your first set of parentheses, which is a 3, you add what's in your last, which is a 2x minus y. And then you take what's inside your first set of parentheses, which is a 3, minus what's in your second set of parentheses, which is a 2x minus y. Now notice I put the minus here and I put parentheses around 2x minus y, because that negative has to change the sign of everything that follows it. So we're going to have 3 plus 2x minus y times a negative out in front flips the sign of everything inside. So it becomes a negative 2x plus y. And that's our answer. Okay, one more difference two squares. We've got x to the fourth minus 16. GCF. There is no GCF. Groupings. 4 more terms. That doesn't fit. PSD and key number, both 3 terms. That doesn't fit. Dots. 2 terms of minus string it. That fits. So we're going to try to write it as something squared minus something else squared. Well, x squared times x squared gives you x to the fourth. Or going backwards, 4 divided by 2 gives you 2. Not backwards, go in that direction. 4 times 4 gives you 16. So we were able to write it as something squared minus something else squared. So we'll take what's inside our first set of parentheses, and we add what's in our last, and we take what's inside our first, and we subtract what's in our last. But if we look at the x squared minus 4, this is 2 terms of minus between it again. And x times x gives you x squared, and 2 times 2 gives you 4. So we try to do it again. Try to write it as something squared minus something else squared. Well, we already said x times x gives you x squared, and 2 times 2 gives you the 4. So this is x squared plus 4. And then we take what's inside our first set of parentheses, we add what's in our last, and we take what's inside our first, and we subtract what's in our last. Now we can't go further because nothing times itself gives you the x, or nothing times itself gives you the 2. So those are our answers. I didn't try to go any further in these previous problems because of the same reasoning. Like this one right here, 4x minus y. Well, 2 times 2 gives you 4, but nothing times itself gives you the x. Nothing times itself gives you the y. So that's why I didn't even bother in that. I want to be referring to number 6 and number 7, but I have to start a new page. So keep those in mind. Okay, so on this one we got x to the third plus 27. GCF. They don't have anything in common. Grouping. 4 more terms. Well, this is 2 terms. That doesn't fit. PSD and key number, both 3 terms. That doesn't fit. Dots. Difference two squares. 2 terms of minus string it. Well, there's a plus between this, so that doesn't fit. I go to my number, the 6th one. Difference of 2 cubes. 2 terms of minus string it. Well, that doesn't fit. There's a plus between it. I go to my last one, which is the sum of 2 cubes. And the sum of 2 cubes says 2 terms with a plus between it, which this fits. So we're going to try to write it as something to the third power plus something to the third power. This is similar to the difference 2 squares, the kind of thought process. But instead of asking ourselves what times itself gives you this, you ask yourself what times itself 3 times gives you this. Like x to the third. X times x times x gives us x to the third. And the 27. 3 times 3 times 3 gives you 27. Now I'll label this as F for what's in my first set of parentheses. I'll label this as L for what's in my last set of parentheses. And our formula says F plus L times F squared plus FL screw up my sign. Minus FL plus L squared. Now let me double check that. I was thinking about food. I smell some kind of good food in the house. And it's derailing me. Okay, that's right. Now, wherever I have an F, I'll put an X, and everywhere I have an L, I'll put in 3. So we have x plus 3, and then we have x to the second power minus x times 3 plus 3 to the second power, which gives us x plus 3 times x squared minus 3x plus 9. Now this looks like you could use the PSD method on it, but you can't. Unless it's just totally bizarre. I've never been able to use a PSD or key number to go further on these. For the sum of two cubes and difference of two cubes. Okay, let's look at our next one. We've got m to the 6 minus 8 m to the third. Okay, GCF. There isn't any. Groupings, 4 more terms, that doesn't fit. PSD and key number are both 3 terms, that doesn't fit. Dots, difference 2 squares. That fits, 2 terms of minus string it. So we try to write it as something squared minus something else squared. Well, this would be m to the third. What times itself gives you 8? Nothing. Difference 2 squares fails. Now go on to the next one. Difference of 2 cubes. Difference 2 cubes says 2 terms of the minus string it. It's the same form as a difference of 2 squares. So if difference of 2 squares fails, you go on to difference of 2 cubes. And we try to write it as something to the third power minus something else to the third power. And just like the sum of 2 cubes, you ask yourself what times itself 3 times gives you that. Well, this one would be m squared. A very easy way to figure out what this should be, take whatever power you have here, which is 6, divide by the 3, and that gives you 2. Now for the 8, 2 times 2 times 2 gives you 8. And for the n to the third, n times n gives you n to the third. So we were able to rewrite it as something to the third power minus something else to the third power. And this is the formula again. I'll label that as F for what's my first set of parentheses. I'll label that as L for what's my last set of parentheses. So our formula is F minus L, F squared plus FL plus L squared. And now everywhere we have an F, we'll plug in M squared, and everywhere we have an L, we'll plug in 2N. So we have M squared minus 2N. And here we have M squared to the second power plus M squared times 2N plus 2N squared. Just plug in our formula, which gives us M squared minus 2N. When you're raising one exponent to another exponent, you multiply the exponents. 2 times 2 is 4, so this is m to the fourth plus 2m squared n, and 2n times 2n gives us 4n squared. And that'd be our answer. Scroll down here. Let's take a look at this one. We've got 81 x to the third plus 24 y to the third. Now if I dive right in with the sum of 2 cubes, nothing times itself gives you 81. And nothing times itself 3 times gives you 81, I should say. And nothing times itself 3 times gives you 24. So it appears like it's prime again. But remember, our first method is always GCF. And for GCF, these both are divisible by 3. So I factor 3 out, and that gives us 27x to the third plus 8y to the third. Now looking at what's inside the parentheses, grouping, 4 more terms, no. PSD and key number, both 3 terms, no. Difference 2 squares, difference 2 cubes, both 2 terms of minusing it. So then I get to my last one, which is the sum of 2 cubes. And I'm going to try to write this as something to the third power plus something else to the third power. Well, we'll look at the 27 first. You ask yourself what times itself 3 times gives you 27. 3 times 3 times 3 gives you 27. The x to the third. X times x times x gives you x to the third. For the 8, 2 times 2 times 2 gives you 8. And for the y to the third, y times y times y. So I'll label that as f. What's my first set of parentheses? I'll label that as L. What's my last? And the sum of two cubes formula was f plus L times f squared minus fl plus L squared. 3 carries down, and now everywhere I have an f, I'll plug in 3x, and everywhere I have an L, I'll plug in 2y. So we got 3x plus 2y, and then we got 3x second power minus 3x times 2y plus 2y to the second power. So that gives us 3x plus 2y. 3x squared, 3x times 3x is 9x squared, minus 3 times 2 is 6, xy, 2y squared. 2y times 2y gives us 4y squared. Now it always looks like you can factor that further, but you can't. There'd have to be I believe a 12, 12 in here in the middle for you to go further than that. So that's our answer. And that was the last problem. So let me go ahead and save this.